Good morning, students. Welcome to my YouTube channel. Today's topic is eigenvalue problems. So first of all, we will study about what are the applications of eigenvalues and eigenvectors. First application is when we diagonalize the matrix for different eigenvalues. In that case, we used the concept of eigenvalues and eigenvectors. Secondly, when we have to solve the first order differential equations or second order differential equations, we need eigenvalues and eigenvectors. Then in Google's page rank, we are in need of eigenvalues and eigenvectors. Then in electronics, when we are studying about RLC circuits, in that we are in need of eigenvalues and eigenvectors. Then in Markov's processes, we use eigenvalues and eigenvectors. So because of these applications, this topic is quite important. Now, how to define eigenvalues and eigenvectors? So, first of all, condition on the matrix A is that A should be a square matrix. So, let us assume A be a matrix of order n. Now, let us take x be a non-zero vector. So, if I multiply x with A, its direction get changed, but we are interested only those vector x whose direction remains the same as ax. This means you can say that ax is directly proportional to x. So when you remove this proportionality sign, you will get lambda, where lambda is the constant of proportionality. Now the equation becomes ax is equal to lambda x, which is given as number 1. So lambda is the constant of proportionality. Now this can be written like A minus lambda I and x is equal to 0, where I is the identity matrix and lambda is a scalar. So in this, if I take the determinant of A minus lambda I and I put it equal to 0, then it becomes the characteristic equation, or you can say this is the latent equation, or eigenvalue equation. So in this you can see that when I have the equation A minus lambda I x is equal to 0, now x is equal to 0, this is always the solution of the equation 1 for any value of lambda. But we are searching those values of lambda for which x is not equal to 0. So those values of lambda are said to be eigenvalues or characteristic values or latent roots. And the values of x which corresponds to the non-zero values of lambda, those are said to be eigenvectors. So in this way, we introduce the concept of eigenvalues and eigenvectors. Now, what do you mean by algebraic multiplicity? Algebraic multiplicity is the order of the eigenvalue. Say you are solving the characteristic equation and you are getting the values of lambda as 1, 1. So, in that case, algebraic multiplicity of lambda will be 2. Now, what do you mean by geometric multiplicity? Geometric multiplicity is the number of linearly independent eigenvectors corresponding to A. That is said to be geometric multiplicity. So when we solve the questions, in that it will be clear to you what do you mean by the algebraic as well as the geometric multiplicity. So the first question is, find the eigenvalues and eigenvectors of the matrix A having entries first row as 1, 4 and the second row as 3, 2. So first of all, we will write its characteristic equation. So characteristic equation of A is given by A minus lambda I determinant, which is equal to 0. So lambda gets subtracted from 1 and 2, and now just solve the determinant. You will get an equation lambda square minus 3 lambda minus 10 is equal to 0. So which say quadratic equation. So when you solve its quadratic equation, you will get the values of lambda as minus 2 and 5. Now corresponding to each value of lambda, say lambda is equal to minus 2 and lambda is equal to 5, you have to find the eigenvector. So first of all, for lambda is equal to minus 2, I will find the eigenvector. So the equation was A minus lambda I x is equal to 0. So lambda is our minus 2. So the equation becomes a plus 2i x is equal to 0. Now a plus 2i, it may be written like matrix A plus 2 times the identity matrix. So when you solve it out, you will get the matrix 3 4 3 4. So you are getting 3 4 3 4 x y 0 0. Now I apply the operation R2 R2 minus 2R1. So entries of the second row get subtracted from the entries of the first row. So what you are getting, 3 4 0 0 x y 0 0. So you can see that rank of a plus 2I, this is 1. So now solve this equation. So 3 multiplied by x, this is 3x plus 4y is equal to 0. Now you are getting one equation in two unknowns x and y. X is equal to minus 4 by 3y, where y is arbitrary. Now let us suppose y is equal to 1. So if we take y is equal to 1, then what we are getting? We are getting x is equal to minus 4 by 3. So our eigenvector is minus 4 by 3 and 1. Now similarly we have to find for the eigenvector lambda is equal to 5. So if lambda is the eigenvalue, lambda is equal to 5, then what we have the equation? We have the equation as a minus 5i x is equal to 0. So first of all we will write a minus 5i. The entries in the first row are minus 4, 4, 3 and minus 3. Now what I do, I will just try to solve it out. So I will apply the elementary row operations. First elementary row operation is R2 R1 by 4. So what I will get? I will get minus 1, 1, 3 and minus 3 xy. This is equal to 0, 0. Now again apply R3. R3 plus 3 times R1 means in the row 3 R3 you have to add 3 times the elements of the row R1. So what you will get? Minus 1 minus 1 1 0 and 0. So when you solve it out, you will get minus x plus y is equal to 0. So let us assume y is equal to 1, then your x, this will be x is equal to 1. So our eigenvector is 1 1. Now we discuss about the properties of the eigenvalue. So first property is if A is a matrix and lambda is the eigenvalue of that matrix A, then if you have A dash, then A dash has the same eigenvalue, which is lambda. Next property is if lambda is the eigenvalue of A and if I multiply lambda with some scalar alpha, then alpha into lambda, that will be the eigenvalue of A into alpha, where alpha is some scalar. Next you have sum of the eigenvalues of a matrix is equal to sum of the elements on the principal diagonal. So you can see that eigenvalues, say A is a matrix of order 2, then the sum of eigenvalues. So whatever eigenvalues you are calculating, those will be equal to sum of the elements on the diagonal. Next is product of the eigenvalues. This is equal to determinant of A. Say you have a matrix A and its eigenvalues are, say lambda is equal to lambda 1, lambda 2, lambda 3. Then multiplication of these lambda is lambda 1 into lambda 2 is into lambda 3. This will be equal to determinant of A. Next is if lambda is the eigenvalue of A, then 1 by lambda, that will be the eigenvalue of 1 by A. Next property is if lambda is the eigenvalue of A, then lambda raised to power m is the eigenvalue of A raised to power m. Now one result is there, but what the result says, if eigenvalues of a matrix are distinct, then eigenvectors are linearly independent. But if eigenvalues are repeated, say lambda is equal to 1 1 2, so lambda value of lambda get repeated as 1 1. So if values of eigenvalues get repeated, in that case the eigenvectors, they can be linearly dependent or they can be linearly independent. This is the quite important result. Next question is, find the eigenvalues and eigenvectors of the matrix A. Now I have a matrix A of order 3 having these entries. So first of all, we will write the characteristic equation corresponding to A. So characteristic equation will be A minus lambda I, which is equal to entries of the matrix A minus lambda entries of the identity I. Or this is equal to A minus lambda I determinant. Put it in the form of determinant, which is equal to 0. Now solve it. On solving it, you will get the values of lambdas as lambda is equal to 1, lambda is equal to 2, lambda is equal to 3. Now these values, all values are distinct. So you can check the values of lambdas, that whether they are correct or not. So if you add these three values, 1 plus 2 plus 3, this will be equal to the sum of the diagonal elements. If these two coming out to be equal, then we say that our eigenvalues are correct. So that is the way to check, right? Next you have A minus lambda I x is equal to 0. Now for each value of lambda, I have to find eigenvectors. So let us take lambda is equal to 1. So I have taken lambda is equal to 1. So just substitute it over there. 1 minus 1 0. So I am getting this matrix. First row as 0 0 0 0 1 1 2 0 2, and then x is xyz, and entries on the right hand side are 0 0 0. Now you can check from here that rank of A minus I, this is equal to 2. Now I will just multiply these. So on solving it, you will get y plus z is equal to 0, x plus z is equal to 0. Now you are getting two equations in three unknowns, and unknowns are x, y and z. So we have to assume 1. So let us take z is equal to 1. So if I take z is equal to 1, I will get x is equal to minus 1, y is equal to minus 1. So the eigenvector becomes minus 1, and 1. Now for lambda is equal to 2, I have to find the eigenvectors. So again the equation is A minus lambda I x is equal to 0. So the equation, what it becomes, A minus lambda 0 0 0, 2 minus lambda 1 2 0 3 minus lambda, eigenvector is x, and this is the null matrix. So let us take lambda is equal to 2. So just put the value of lambda is equal to 2 over here and solve it out. So you will get this matrix. Now multiplying or solving this matrix, so what you will get, minus x plus 0 y plus 0 z, and next equation is 0 x into 0 y plus 1 z is equal to 0. Then 2x plus 0 y plus 1 z is equal to 0. Now I apply, or he has not directly multiplied, he is just applying the some operations so that it gets simplified. You can do it directly or you can apply some elementary row operations on it. It depends upon you. What do you want? So R3 plus 2R1. So I am getting these entries. Then from R3 subtract R1. So you will get the resultant matrix as minus 1 0 0 0 0 1 0 0 0 x y z is equal to 0 0 0. Now you can see that rank of A minus 2I, this is equal to 2. So multiply these. Minus 1 into x is minus x is equal to 0 or x is equal to 0. Then z is equal to 0. Then you have 0 into x plus 0 into y plus 0 into z is equal to 0. Now here y is arbitrary. So let us take y is equal to 1. So the eigenvector will be 0, 1 and 0. 0, 0, 1. Next you have A minus lambda I x is equal to 0. Now this is for lambda is equal to 3. So I have taken lambda is equal to 3 over here. Then I apply the elementary row operation as R3 plus R1 means entries of R3 they get added to the entries of R1. So the resultant matrix will be in this form. Now solving it out. So minus 2x is equal to 0. Minus 2 is a constant. So ultimately you will get x is equal to 0. Next equation is minus y plus z is equal to 0 or y minus z is equal to 0. So let us take y is equal to 1, z is equal to 1. So when you take y is equal to 1, z is equal to 1, x is equal to 0. So our eigenvector becomes 0, 1 and 1. So this is all about eigenvalues and eigenvectors. So today we have studied about how to find eigenvalues. Those are found with the help of characteristic equation, and then you have to solve A minus lambda I x is equal to 0 for finding eigenvectors. And one important result that was discussed, if your eigenvalues are distinct, in that case your eigenvector will be linearly independent. But if your eigenvalues get repeated, in that case your eigenvectors they can be linearly dependent or they can be linearly independent. So thanks for watching the video. Please subscribe, like and share the video as early as possible. Thanks again.